Hello viewers, welcome back again. Today we are going to continue the same topic that we have left in our last class. So we are discussing about the reference frame. Okay, so we have discussed about the two reference frame, that is 1D reference frame, 2D reference frame, and today we are going to discuss about the 3D reference frame. Got it? So let's start 3D reference frame. Okay, now 3D reference frame, we have to draw the three coordinate. This is my origin, this is, let us say, this is my x-axis, this is my along y-axis, and this is my z-axis. Now I will consider a point or a particle exactly here in a space, okay, somewhere here, which has some distance from the x-axis and from the y-axis as well as from the z-axis. So that time, let us say my p is here. What is p? P is my any particle or point which is in this space right now. Okay, that means it has some distance from all the axes. And let us say from the origin it has a distance of r. Okay, it has a distance of r. So what is r? R is equals to linear distance from origin O. Okay, so now to know the positions of that point P, to know the exact location of point P, we have to know the three things in case of the spherical coordinate. Okay, if an object lies in the space, that time we have to know the three things, that is the three coordinate. Okay, so number one coordinate is given by R. Now we need two more coordinate to know exact position of point P. So this next coordinate will be theta. Okay, so this theta will give the direction, give the second coordinate of the point P. But what is theta? Theta is my polar angle. Okay, what is my theta? Theta is my polar angle. It is made by OP with respect to opposite axis. Do you understand that? So OP is theta is an angle or polar angle made by OP along with respect to opposite axis. Now we need one more, the last third one, the last coordinate to know exact position of point P, and that will given by, let us draw the dotted line exactly from point P on the y-axis. Okay, so I'm drawing a perpendicular from point P on the xy plane. Okay, so this is my xy plane. I'm drawing a perpendicular from the point P exactly on xy plane. Okay, so this is my xy plane, and we will draw till point OP. Okay, sorry, point P dash. Okay, and we assume that OP will be equals to OP dash. Okay, not assume, that will be equal. Okay, that means this OP and this OP dash will be equal. Okay, so that time if I draw the angle here like phi, that will give the third coordinate of the point P. Now I have all the three coordinates. Now this is completely fine to define the positions of the particle right now. Okay, so what is phi? But phi is in, this is called the azimuthal angle. Do you understand that? It is made by OP dash with respect to OX axis. Understood? So we have three coordinate. R is the linear distance of point P from O or origin, and next is theta. Theta is my polar angle made by OP with respect to OZ axis, and last thing is the phi. Phi is an azimuthal angle made by OP dash with respect to OX axis. And what is OP? OP dash is a actually we have drawn a perpendicular line from the point P on the xy plane, and if you extend that, if you join that O and P dash, you will get equal length to that to that OP. Okay, this R is called as a linear coordinate, and this 2 theta and phi are called as a spherical coordinate. Do you understand that? So R is my linear coordinate and theta is my theta and phi is my spherical coordinate. Got it? Okay. The range of, let us say range only. Okay. Range for R is less than, or sorry, greater than or equals to 0. That means it can be anything, but it cannot be negative, but it can be 0, and it can be anything more than that 0. Okay, but it cannot be 0. Okay, it can be 100,000, 10,000, lakh, it can be anything, but it cannot be negative. Okay, and for theta, it is, the range is from 0 to 180 degree. That means minimum is 0, it cannot be again less than negative, less than 0, and it cannot be more than 180 degree. So it can be 0 to, range will be 0 to 180 degree. And for phi, the range is the highest, that is 0 to 360 degree. Do you understand that? So what is the range? Range means, like, if you rotate this angle, you can rotate this till only 180 degree. Understood? This theta, understood, polar coordinate. And then phi azimuthal angle also, you can rotate by a 360 degree angle, completely one rotation. Understood? Okay, now okay now our earth is also spherical in shape, no? So any, just imagine this point B is exactly on the earth surface. Okay, this point P is exactly on the earth surface. This is my earth. So this point P is exactly on the earth surface. Then how will define the positions? To define the positions of the of any object on the earth surface, two things is enough, because the positions, this R will be equivalent to the radius of the earth, that is 64,000 kilometer. And then theta and phi will give the locations of any object situated on the earth surface. What is theta and phi? Theta and phi is, the theta means, like here, latitude, and phi is my longitude. Okay, so theta will give me the latitude, and then phi will give me the longitude. Okay, so now if theta is the latitude, theta is the polar angle, then latitude will be equals to 90 degree minus theta, because this is my latitude. Yes or no? This is my latitude. And what is my azimuthal angle? Azimuthal angle will be like phi only. Understood? Clear? Okay. Now the next thing is, mm, now now the next topic will be rotation. Now the next topic will be rotational. Now now the next topic will be translational motion and the rotational motions. If you look at the motions, there are two types of motion. Number one is this translational motion, and number two is your rotational motion. Do you understand that? So we have two types of motion. One is rotational motion, another one is the translational motion. Translational motion means, like, it is a linear motion. Okay, that means any object moving on a straight path or a straight line is called as a translational motions. Like, example can be given as, let me write the definition: moving in a straight path. Do you understand that? Okay, example, car moving, a car moving along a straight path. So that gives the definitions or example of the translation motion. So in translation motion, there is no change in direction. It will go in one direction, one direction, one direction. Okay. In rotational means if any object moves around a circular path, okay, with a fixed axis, that is called the rotational motion. Okay. So in rotational motions, uh, moves around a circular path. Clear? So here the particle moves around a circular path. Example like spinning top, घुर्ना हैन घुर्रा घुमाउँदैछ हैन. If you are spinning a top, that is your rotational motions, like wheel of a car, wheel of a moving car, moving wheel of a moving car. No, when the wheel moves, it will moves around a circular path. So that is the example of the rotational motion. You can give the other examples also. Okay. Now let us discuss about the characteristics of the both type of motion. Let us discuss one by one. Translational motion. In translational motion, number one characteristics I can write. Number one, the according to the definition, it moves in a straight path. No, if it moves in a straight path, so no change in direction. Yes, no change in direction. Okay, so no change in direction. Okay, similarly, let us write for the rotational motion. Rotational motion. So, one, what will be the? Of course, we are going to write the definition one only. Moves in a circular path. Circular path. Number one. Number two, there will be change in direction. That is continuous. There will be change in direction. How? Let me explain you. Let us say this is my circular motions. Okay, right now the particle is here. After a few seconds the particle will be here again. After a few seconds the particle will be here. How to know the directions of the particle exactly at the point? Let us say this is point A, this is point B, and this is point C. How to know the positions? Okay, to know the positions of a particle in a circular path, we have to draw a tangent. Okay, what is a tangent? Tangent is a straight line which tosses the curve or circle only at a one point. Okay, so that will give the direction of the object or any particle at that point at any instant. Okay, so right now the direction is this way, but after a few seconds the direction will be this way. If I draw the tangent here, again if I draw the tangent here at point C, the direction will be this side. So what did you see here? The directions of the object are continuously changing. After a few seconds at the point P, the direction is different. After a few seconds the time at point C, the direction is different. That is why the direction continuously changes in a circular path. Direction changes continuously. Direction changes Neously, continuously. Direction changes continuously. Got it? Okay. Now keep the notes also, please. Okay, now let's compare the two types of motions. Okay, let's comparison. Let us compare. Comparison. Okay, so comparison number one, translational motion. Here we'll have rotational motion. Doesn't mean you have to rotate, no? Just a motion. Okay, so number one. So translational motions, moves in a straight path, same, moves in a straight path. Rotational motion moves in a circular path. Okay, number two, direction is same, direction is fixed. Here, number two, direction changes continuously. So what did you say? So here I have written the same. I have copied the same thing of the characteristics, like translational motions. That characteristics and comparison can be right in the same way. Okay, if you compare them, it becomes a comparison. If you write separately, it becomes a characteristics. So that is the tricks to write the answer. Okay, so that is the clever way to write the answer. Got it? Okay. Now another type of motion is not only these are the two types of motions. We have one another third type of motion, and that motion is called as a complex motion. What do you call it? Is called as a complex motions. What is a complex motion? Like sometimes what happens, we'll have rotational motion as well as the translation motion simultaneously. Like for example, just imagine the wheel of a moving car. Okay, at the same time the wheel of the moving car, what is happening here, the wheel of moving car is moving in a straight path as well as it is rotating also. Yes or no? So here you saw both type of motions which is occurring simultaneously, translational as well as the rotation. So this type of motion where you can see both the type of motions, rotational and translational simultaneously, then we call that type of motion as a complex motion. Okay, it is the type of motion where translational as well, let me write properly, as well as rotational motion occurs simultaneously. Example, wheel of a moving car. Okay, now you are confused, like we have written the same example with the rotational motions. No, yes, we can write for both. So just imagine you are not that wheel of the car is not rolling over the surface. That time just we are just spinning that wheel of the car. Okay, so that time we can say it is a rotational motion. Okay, you are not that wheel of the car is not moving. Okay, that time we can consider it as a rotational motions. Now if the wheel of the car is moving on the ground as well as if it is rotating, that time we call this type of motion as a complex motions. Got it? Yeah. Okay, so the next topic is displacement. What is displacement? Like displacement means, like if I have object here exactly here, and now if the object goes and moves to the point this here. Okay, first object was here, now the point is here. Now when it changes its positions through a certain distance, okay, it can go like here. Why I'm saying certain distance? Because it can follow any other path, like it can go like this, it can go like this and then reach here. But why it is following this, and then what do you call that path? And that path is exactly called as a displacement. Okay, so displacement means this is the shortest distance shortest distance between any two point. Okay, so displacement means it is a certain point between any 2 points. If the object, one object here is here and another one is here. Okay, now it can follow any other path, like it can go follow the path one. Let us say this path one, it can follow this path also. This is path two, it can either follow this path three. Okay, but if there is, but in all the three paths, their initial and the final path same, yes or no? If it here also for path A, path one also the starting point is A, for path B, sorry, path and end point is B, and for two also the starting point is A and final point is B. Similarly for three also starting point is A and ending point is B. Okay, so now what will be displacement in all the cases? Means in all the cases, in all the three paths, the displacement will be equals to AB. Why AB? Why displacement will be equals to AB? Because displacement is the shortest distance. Okay, it is the shortest distance between any 2 points. Okay, so doesn't matter whether it follows the path 2 or path 3 or path 1, the shortest distance will be called as a displacement. So right now the displacement is path A. Okay, that is why displacement is equals to AB. Got it clear? Okay, now from here it is clear that displacement is a path independent. Okay, it is path independent. That means doesn't matter, doesn't depend on it, on the path. Okay, whether you follow this path, this path, or this path, it is independent of the path. What matter is that the initial and the final point. Okay, now let us consider a case in which an object, an article, a particle is moving along the direction east. Let us make this first: east, west, north, and then south. Okay, let us consider in which a particle is moving along the distance x, sorry, east. Okay, now let us say this is 4 meter, and now if suddenly if it moves the distance 3 meter towards the north. Okay, first the particle was moving towards the east with a distance of 4 meter, and now the particle is moving towards the north with a distance of 3 meter. What will be the what will be the distance between the point? Let us say this is initial point A and this is my final point. Now what is the displacement between the point between this in this case, let us say, okay, in this case, now if you go this and here, that is not going to be the shortest distance. What is the shortest distance here? Here the shortest distance between the point A and point B is my dotted line. Okay, so displacement will be given by displacement, let us say this is here, displacement is given by AB, and if you look here, this is exactly 90 degree, and if you use the Pythagoras theorem, it will be equals to 4 square plus 3 square base perpendicular hypotenuse. So hypotenuse square is equals to square root of base square plus a perpendicular square. So it will be 16 plus 9, so it will be 25, so it will be 5. So AB will be equals to 5 meter. Okay, so AB is the displacement. Okay, okay, now the next thing is its unit. SI unit is, what is the SI unit? Meter per, sorry, meter. And what is the CGS unit? CGS unit is centimeter. Got it? Okay, the first, the SI unit is meter and the CGS unit is centimeter. Okay, now let us consider a case. Let us consider another case in which the particle is moving in a circular path. Then what will be the distance and the displacement? We have to find it. Okay, let us say a particle is moving in a circular path of radius r. Can you calculate the distance and the displacement if the particle moves around a circular path? Can you find? Okay, let us do one by one. Okay, let us say the initial point is A, and let us say this point is B. Okay, now the particle will start from point A, and then it will move, and suddenly after some time it will reach at point B. Okay, can you calculate the distance? Let us say R is equals to 4 meter. Okay, 4 meter. Let us say R is equals to 4 meter. Can you calculate the distance, or what will be the distance if the point, or the if the point or particle reaches at point B? At B, at B, distance. First, let us say distance. Distance is equals to, what will be the distance? Can you calculate? If you look here, from here to here, it is a semicircular arc. Yes or no? It is a semicircular arc. Semicircular arc. For circle, the distance is the, for circle, the length is the 2 pi r, that is the circumference, and from A to B, it is my only the semicircle. So distance will be pi r, and here r is equals to 4. So that is why 4 pi. Clear? So 4 pi meter is the distance. Yes or no here? But what will be the displacement? What will the displacement? Now displacement means, like we have already discussed, it is shortest distance between the point, 2 points. Okay, so from here to here the shortest distance is this one. So this one means from here to here is 4, and from here to here is again 4 meters. So displacement will be equals to 8. 4 plus 4 will be 8 meter. Clear? Now again, if the particle rotates and reach at point A, what will be the displacement and the distance at A? Displacement and distance. First, let us calculate the distance. Okay, so distance will be equals to, now it will completely covers a circular path. Yes or no? So distance will be equals to 2 pi r, that means the circumference. That means it will be pi r is 4, so 4 2s are 8 pi meter. And what will be the displacement? Now look at here. In this case, the particle is moving here, move here, starting from here point A, and then again rotate and rotate and rotate and rotate, and then not rotate, it revolves around this path and then reaches again the point A. Okay, so now in that case, the starting point and the final point for in that case is same. Yes or no? Starting point is also A, final point is also A. So in that case, we can say the displacement is 0 meter, because the particle is not changing its position anymore, because the particle was first here, and again now after some time the particle is again here. So there is no any change in the positions right now. So that is why the displacement is 0. Understood? Clear? If you want to take the notes, take it. So from these things, we came to one conclusion. And what is that conclusion? The conclusion is distance is a scalar quantity, and displacement is a vector quantity. Okay, why it is a vector quantity? Because it matters with the direction, with the direction also. But in case of displacement, we don't care about the distance, displacement, direction. Okay, but in displacement we have to care about the direction also. That is why it is a vector quantity. Got it? Okay, so if it is a vector quantity, then it must have to both the things. That means it will have the direction as well as the magnitude also. Got it? Okay, now the next thing is speed. What is speed? Like, speed is like, it is the rate of change of distance. Okay, so it is the rate of change of distance with time, or we'll write with respect to time. Okay, so with respect to time, so it is the rate of change of distance with respect to time. Rate means it is a comparison like ratio. Okay, we are comparing, we are comparing speed with the distance and time. Okay, so this is a comparison between the distance and time, that is why we have written rate. So it is a comparisons, it is the change of distance over a time, or over a given, over a certain given time. That is why it is speed is equals to distance upon time. Okay, so if it is represented like distance upon time and distance is scalar quantity, so speed must be a scalar quantity, because distance is also a scalar quantity. Scalar quantity, so it is scalar quantity. Now unit, unit will be SI unit and CGS unit. Where is my C? Okay, CGS unit. So SI unit is meter per second. Okay, or sometimes we'll write ms to the power minus 1 also. Okay, or here centimeter per second. Like for time, the unit is same either in whether in SI or CGS, it is always centimeter. Okay, similarly for this also I can write same s to the power minus 1. Got it? Okay, if you want to write dimension also, we can write dimension. Dimension will be m to the power 0. Mass is 0, yes or no? Here in this case the mass is 0. We have length, because meter means it is the length, yes or no? So L, and time is in inverse, so t to the power minus 1. Okay, so this is the dimension of speed. Okay, got it? Clear, 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 clear. Okay, now if you look at the speed also, we'll have two types of speed. One is the uniform speed, another one is the non-uniform speed. What is uniform speed? What is non-uniform speed? Let us discuss one by one. In uniform speed, an object will cover equal distance in equal interval of time. Let us say A, B, C. Okay, I have considered 3 points, a distance from A to B. Let us say it is a 2 meter, and from B to C pani it is 2 meter. Okay, now if any object takes the same time, like from A to reach from A to B, if it takes time 2 seconds, and from B to C, let us write 3 seconds. Okay, why I'm writing 3 seconds? Because some of you might get confused with the 2 every time we have to write 2 but it is not the thing. Okay, so that is why I'm writing 3 seconds. Okay, so if an object takes 3 seconds to reach from point A to B, in another next 3 seconds, if it cover the same distance like 2 meter, then this type of motion is called sorry, this type that type of motion is called as a uniform speed. Okay, again in the next 3 seconds it will cover a distance of 2 meter. Okay, so another next 3 seconds it will cover, again going to cover the 2 second. So like here, what did you saw here? For equal interval of time, the distance covered is same. So this type of motion is called as a uniform speed. Here equal covers equal distance in equal interval of time. Clear? Okay, now non-uniform motion. Okay, in non-uniform motions, like if it is taking now, if it is taking to reach from A to B, if it is taking a time, let us say 1 second, and here 2 second, and here 3 second, yes or no? Now for the same distance they are taking different times, so that means the speed is not uniform. So this type of speed is called as the non-uniform motion. So covers equal distance but distance but in unequal time interval. Understood? It covers equal distance but in unequal time interval. So this is the non-uniform motions. Okay, clear? Okay, average speed. Okay, to measure the speed, it is not the type of the speed, but sometimes we have to measure the speed in terms of the average, sometimes in terms of the instantaneous. Okay, it is not different types of speed. Okay, we have only two types of speed. One is instantaneous, another one is the sorry one is uniform motion speed and another one is the non-uniform speed. But why do we need average speed and instantaneous speed? Sometimes we have to, according to the situation, we have to find the average value of the speed, and sometimes we have the instantaneous instantaneous speed. Okay, that we will discuss one by one. Okay, so how to find the average speed? Like, first let us go with the average speed. Okay, so how to find the average speed? Let us say an object cover a distance L1 in time t1, L2 in time t2, L3 in time t3, and so on Ln on time tn. Okay, so these are the different distance covered in different time. Like in t1 time it covers a distance of L1, in t2 time it covers a distance L2, and similarly. Okay, now in that case we cannot say that total distance is equals to like how to find. No, we cannot say total speed is equals to L1 by t1. It is not the total speed. No, so in that case we have to use the concept of the average speed. And how to find the average speed, how to calculate the average speed? Speed is usually denoted by u later. So let me write UAV. UAV stands for average speed. So it will be equals to L1, L2, L3, L1 plus L2 plus L3 and dot 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 Ln. Okay. Similarly, divided by speed is equals to normal distance upon time. So time t1 plus t2 plus t3 and so on till tn. Okay. So that will gives us the idea of the average speed. Okay, so this is the one way to find the speed of any particle or any object. Okay, now sometimes we have to find the speed instantaneously. Instantaneously means like at a particular time. Okay, instantly we have to find, and that type of speed is called as a instantaneous speed. Okay, like I'm writing here, what is the speed here? When I'm writing here, what was my speed here? So that time, whatever the speed I will get, that is called the instantaneous speed. Got it? Okay. Okay, so instantaneous speed can be that means instantaneous speed. For instantaneous speed, time will be almost zero. So to find the instantaneous speed, ui, our time limit tending to zero. Okay, that means time is almost zero but not zero. Okay, we don't count this as zero, but time will be very small. It will almost zero. So that time I can write del L by del T. Okay, change in length or change in distance over change in time. Del means change in time or change in length. So as a whole I can write ui means instantaneous speed is equals to dl by dt. Okay, so that will gives the idea of the instantaneous speed. Clear? Okay, clear now the difference between average and the instantaneous speed. Okay. Ayo. Okay, next thing is the, okay, now uh, let me explain you with this. Now let me explain one thing, like how will measure the speed of a car or speed of any vehicle. How will measure the speed of uh, that any vehicle. So to measure the speed of any vehicle, there will be a meter in that fitted into that um, car. Okay, so that will gives you the speed of the car. But what do you call this meter and what does it measure? So this is actually called as a speedometer. So speedometer is used to measure the instantaneous speed. Do you get it? Okay, so speedometer is a meter which measures the instantaneous speed of any vehicle or any car. Okay, so now I'm saying that like instantaneous, or let us write like when the speed is uniform, instantaneous speed will be same as the uniform speed. Okay, I'm saying that when the speed is uniform, okay, when a car is moving with a uniform speed, that time that speed is actually called as a instantaneous speed. So instantaneous speed and uniform speed can be same when the object is moving with a uniform speed. Okay, now like when the car is moving with certain velocity, and that time if it is not changing its velocity, that time that pointer will shows in a fixed number. Okay, like 20 meter per second, like 20 kilometer per hour, like 30 kilometer per hour, it will show like that, no? So if it is not changing, if it's fixed at that time, that means the part that car or the vehicle is moving with a fixed speed. So in that case, we can say that the speed is actually the instantaneous speed. Do you get it? Understood? Clear? Okay.